Erika Swanson is a senior in the biology program at Bethel University in St. Paul. After graduating, her plan is to attend graduate school to study conservation biology or ecology. Her research focuses on comparing the presence of avian populations during and outside of rush hour times to determine the effect of traffic noise. Erika.
Okay, thanks, Clint. Can everyone hear me? Okay, perfect. As he said, my name is Erika Swanson. I'm a senior at Bethel University. I'm a bird watcher, which certainly does not put me in the minority here. And I have been since I was about 5 years old. I have been involved in various bird researches since my sophomore year of high school. For example, MAPS, which you guys have already heard a little bit about earlier, which is monitoring avian productivity and survivorship. Last summer, I had the opportunity to help Dr. Port with a project on the Phaethornis genus, which is a genus of hermit species in South America. Unfortunately, I didn't get to go to South America, but I will be going in January, so I'm super excited about that. I will be finishing my biology degree this spring for my undergraduate, and then hopefully going on to grad school in some sort of ecology or conservation biology field. So this summer, I chose to research avian responses to rush hour traffic noise. There have been many examples of infrastructure effects on biodiversity that have been previously explained. For example, Benitez Lopez did a meta-analysis on several different, actually very many studies on mammal and bird diversity, and one of their key conclusions was that there is an effect of infrastructure up to 1 kilometer into the habitat from the edge of that habitat. And they also found, which is interesting, that a couple species actually benefited from infrastructure. Some of these included accipiter hawks, falcons, and rodents, which actually that's not a huge surprise. Additionally, it has been found that agricultural practices decrease biodiversity. For example, McLaughlin and Minot looked at a bunch of different studies that have been done and concluded a few different things. For example, tillage practices can disrupt soil composition, which then makes it harder for plants to grow back, which then can affect numerous species. Draining for agricultural area can decrease habitats for various mammals, waterfowl, and other animals. And then pesticides, like we just saw in the last presentation, can affect insect diversity, and as Jessica pointed out, lots of birds are reliant on insects. When it comes to wind turbines, Mio looked at the effects on bird populations. So if you put a wind turbine in a habitat, what does this do to birds? And they found a decrease in the bird diversity, but there's also some ways to work around it, which is good, such as like taller windmills with shorter blades had a lesser effect on bird populations. And then Gavaretsky looked at reducing park size and found that that decreases diversity in avian populations, as well as clearing brush in those forests that will have a negative effect on populations as well. So when it comes to roads specifically, Kochelek looked at various studies that have been done and looked at edge effects, isolation, and mortality. For example, when you put a road in, this splinters the population into different subhabitats, which then can isolate populations from each other, making it harder for birds to cross those barriers. Mortality, I'm sure we've all seen examples of this with like birds getting hit by cars, for example. And then edge effects happen when you have the road alongside a habitat, the edge of that habitat is affected, and then that effect kind of lessens as it goes into the habitat. So when it comes to road noises, Dooling found that this road noise can mask communication and increase stress. And Paris and Schneider found that when this communication is masked, this can increase the difficulty in establishing territory for birds, which then can also reduce their likelihood of finding mates, and then potentially even disrupting their breeding seasons. So all of this shows us that understanding the effects of infrastructure is really important on improving our conservation efforts of wildlife. And if we can find ways to get around these effects, that'll help us preserve nature for the future. So when it comes to traffic noise, there's a couple other sources to go with this. Near roads, previous literature has shown that there is abundance of most species is lowest near the roads. For example, Reinen found that trend, and then he studied it in the Netherlands. So there's actually been studies done around the world, which is really interesting. And Pollock studied in Poland and found that diversity was also lower near the roads. So we have studies showing that number of birds is lower near traffic noise, and also abundance is lower. However, there have been other studies that have found not as much of an effect of traffic noise. For example, Summers, who studied birds in Ontario, found that the distance from the road actually had a greater effect than that traffic noise. So those would be those edge effects having a greater impact than the traffic noise itself. She found that the avian abundance was maximized at 350 meters, but the traffic noise was minimized further into that habitat at 450 meters. So because of this variability, I was like, well, let's look at some of that and see if I can bring clarity to that, those studies. So for my study this summer, which spanned about 12 weeks, I wanted to investigate short-term effects of traffic noise, whereas previous studies had looked at long-term effects, whether that's over several years or several breeding seasons. And to do this, I wanted to compare abundance during rush hour and then outside of rush hour. A couple other things to note before I go into my methods and discussion results. Habitat can have an influence on bird abundance and diversity. I'm sure you all have had experience with this as you watch birds. Gabretsky found that habitat type influences diversity, so the number of species, but not the abundance. So he was seeing similar numbers of birds in every habitat, but the numbers of species would kind of fluctuate. Foreman found that traffic noise can be absorbed by vegetation, and this will come into play later, especially since the parks that I studied had variable habitat. There were some areas with prairie, and then woodlands and wetlands as well. So for my study, I looked at 4 parks in the Three Rivers Park District. I applied for and received an off-trails permit for these parks. The parks were Elm Creek Park, Fish Lake, Crow-Hassan, and Baker. So they're all west/northwest of the Twin Cities. For my study, I set up transects at each of the parks with 8 points along each. I will go into detail on those in a second, but just to give an example of marking my points, I used biodegradable flagging tape, which is shown in that picture on the left there. And I also used my phone with Apple Maps to put in a GPS location so I could easily find those points later. And then throughout the summer, I went out and collected data, visiting 8 times during the week per park, and then 4 times on the weekend per park. And this gave me my rush hour time, which was my weekday times, and then a non-rush hour time, which was my weekend. And then I analyzed my results to compare the transects as we moved into the parks, and then also to compare those weekday and weekend for the rush hour and non-rush hour. So just to give some examples of habitat at each of the parks, we have Crow-Hassan on the left, which had some prairie area and also some wooded areas. Elm Creek was mainly sparse trees in the area that I studied. Baker Park was primarily wooded, and then Fish Lake had some wetlands, prairies, woodlands, kind of a mix of things there. So I chose each of these parks because they experienced a variability in traffic flow. So there was a significantly higher traffic count during rush hour than outside of rush hour. So here are my transects. Crow-Hassan Park is on the left there, Elm Creek and Baker are in the middle, and then Fish Lake is on the right. As you can see, the transects generally follow the contour of the road. I had a adjusted a little bit due to habitat and trying to avoid some wetlands. These transects were based on Polik's study in Poland. He actually set up 3 transects at 60 meters, 310 meters, and 560 meters. I set my transects at similar distances. They were 50 meters, 250 meters, and 450 meters. And the reason I had them a little bit squished together more than Polik did was because this is what fit the parks, but also because Summers found that traffic volume was minimized at 450 meters, so that's as far as I decided to go into the habitat. And then as I walked along each transect, so as you can see there's 8 points along each. I walked each transect at each park. I'd visit from 6 to 9 in the morning, walking along the transect, counting birds at each point. I did a point count method where I would stand at each point, count the numbers of species and the number of birds for 5 minutes. I would take a decibel reading at each point to gather traffic noise data. And then as I walked along that 50-meter transect, I would also take traffic counts to see just like a sample of what is that traffic flow from weekend or weekday. So I would take a minute sample at each point of the traffic flow. And some things to just notice right now is Elm Creek had the biggest road next to it. There were 8 lanes of traffic. Fish Lake had 4 lanes, and then Baker and Crowhasson only had 2 lanes of traffic. And this plays a role in my results later. So then, once I had collected all my data, I looked at the edge effects. So this is comparing transects as we move away from the road. So I found that the decibel level had significant differences between each transect as we moved into the habitat, and this is what I expected. So I did not have a table for that because they were all significant and it just wasn't as interesting. But the abundance, which is more interesting, is shown in the table here. It was significant for most comparisons, and I have 1 check mark if the p-value was less than 0.05 and a double check mark if it was less than 1,000th. So as you can see, I compared 50 meters with the 250, 250 with the 450, and then that 50 with the 450, and that's shown for each park here. Only one that there was not a difference at was Fish Lake in that 250 and 450 transect. And again, this is looking at data points across the whole summer, weekday, weekend combined, just looking at those edge effects to see if there's a decrease in traffic noise or an increase in abundance. And that is what is shown in this table, or this graph here. This is my data from Crowhasson Park. So abundance is shown in blue, and then the mean decibel level is shown in gray. And as you can see, as we moved away from the road, that decibel level decreased, but that abundance increased. And the numbers on the right here are the number of birds per point in each transect. So you can see that increases. One thing to note right now is richness is not shown here because they generally followed the same trend as abundance, which was actually something that was found in previous studies as well, where you'd usually only see about one individual per species, maybe 2 at each point, so it really didn't have much of a difference. So I chose to just show abundance here. Now to look at some variability among the parks, so here's Crowhasson. The next one to look at is Elm Creek. It's interesting that the abundance actually jumped from 50 meters to 250 meters, a lot higher. So it's kind of almost the opposite of Crowhasson, where it's a bigger jump at the beginning, but still that mean decibel level is decreasing. Baker looked pretty similar to Crowhasson, but you still see the abundance increasing, mean decibel decreasing, and then same for Fish Lake, which was our most linear of the graphs. So next, we will look at my traffic noise effects. So to do this, as I mentioned earlier, I collected on weekdays, which was my rush hour times, and then weekends, which was my non-rush hour times. And I compared those weekday and weekend points, or data points, and the only significant differences that I found in abundance between weekend and weekday was at the 250 meter point and the 450 meter point at Elm Creek Park. This is this graph that's shown right now. So The blue is the abundance, and the gray is the decibel level, like the slides before. The dashed lines, however, are the weekend, and then the solid lines are weekday. So as you can see, in abundance, which is blue, the weekend abundance is higher than the weekday abundance, which is meaning I'm seeing more birds on weekends when there isn't as much traffic than on weekdays when there's more traffic, and then there's higher traffic noise during the week compared to the weekends. Also, just to see, so Crow-Hassan was actually interesting. So yes, the 450 meter was actually higher on weekdays, which is interesting because we still see a higher weekday mean decibel level. So why might this be? Well, if I had all the time in the world and not just that 12-week, which is very short, and it's just my senior project, so hopefully in graduate school I'll be able to do a much longer project. But Crow-Hassan, my weekends were the kind of, ended up being crummy weather, which I did avoid, like thunderstorms and super windy days, but it was still a little bit like not the greatest. So that might have been why that weekend abundance was slightly lower than I would have expected. Or maybe it just could have been that there was not an effect at Crow-Hassan at that point. Given the habitat and the traffic level there wasn't very much traffic at that park anyway, as we'll look at in a little bit. So that may be why I saw that difference there. Baker Park, there was pretty much no difference in abundance from weekend to weekday, but there was still that significant difference in traffic noise. And then Fish Lake was slightly different, but not statistically significantly different. So then why did we see those results? Well, it makes sense that we saw the edge effects where the abundance would increase, mean decibel would decrease as we moved away from the road, and this follows several different studies, such as Pollock, which I mentioned earlier, Long, who looked at 2 to 3 transects depending on habitat size, perpendicular to the road, whereas I did parallel to the road. And he actually found that extended traffic noise effect extended about a kilometer into the habitat, and he looked specifically at prairie and warbler populations. And like these studies, we found edge effects in our park. So one major point to discuss is habitat. So Foreman studied grassland and found an effect that was like 700 to 1,200 meters into the habitat, and this depended on the traffic volume. Pollock studied woodlands and found an effect up to 310 meters from that traffic noise. So when we look at the parks that I studied, Elm Creek had sparse trees, which is closer, obviously, to the grasslands, and we saw an effect at 250 and 450. So why not the 50-meter transect there? Well, when I was out observing, there actually weren't very many birds in the 50-meter transect at all. It was right along 610, so since there weren't very many birds at either times, this would make sense that it was not statistically significant difference. Crow-Hassan was that one that had the higher on the weekday. So there weren't any negative effects. It was also wooded up to 300 meters and did not have as much traffic. Baker and Fish Lake did not have significant effects, and they are wooded up to 400 meters. So this habitat effects then combined with my traffic flow volume may explain why I did or did not see effects at certain points. So Foreman, which again was that grassland study, found an effect of traffic noise with higher traffic flow. So 3,000 to 8,000 vehicles per day had no observed effect. 8,000 to 15,000 had an effect up to 400 meters in grasslands, and then 15 to 30,000 or more had an effect up to 700 meters. So based on my traffic counts that I took, assuming about a constant rate for say 3 hours in the morning, 3 hours in the afternoon for rush hour, and then using some extrapolation for the day, what would be interesting to get would be some actual data for this road, perhaps by like taking a full day, setting up cameras, counting those, but I only took small samples for now. So Crow-Hassan would be likely around 4,000 cars per day, Baker would be around 3,000 cars per day, which would fall into that no observed effect range, and especially since they were wooded, that would absorb the noise and potentially not affect as much. Elm Creek, which had the greatest traffic flow, was in that effect up to 400 meters, potentially a little bit more, which is what we saw had an effect at 250 and 450 meters. And then Fish Lake had around 8,000 cars per day, which is kind of on that edge again of no observed effect and effect up to 400 meters, but again it had wooded area, so that could have decreased the effect as well. So in summary, we found edge effects, looking at the decreased decibel level as we moved away from the road and increased avian abundance. And then we found those differences in abundance on weekdays and weekends at 250 and 450 meters at Elm Creek, which suggests traffic noise effects. So this concludes that we could potentially say that higher traffic flow and less tree coverage may affect the response of avians to traffic noise. So this effect may depend on both traffic and habitat. Some potential future studies to look at would be, do changes in traffic noise affect some species more than others? There have been several studies done to show that there are differences in how species respond to things. For example, Paris and Schneider studied these birds in Australia, the gray shrike thrush and the gray fantail, and found that the gray shrike thrush actually lowered the frequency of their call in response to traffic, where the gray fantail did not. Pollux found that ground and low nesting species actually experienced a greater effect from traffic noise, and this effect was also increased if those species had a low frequency call. And then Long studied warblers and found that construction of a road actually did not negatively affect these populations. He also found that there was not a significant change in noise from before the construction, during the construction, or after the construction at the points he was looking at. So since there wasn't a significant change in noise, this might also play into that effect. Some potential influences to my study were counting challenges. There was dense vegetation in much of the area, so a lot of it was based off of sound, which is going to be mostly like territorial males. We did look briefly at a seasonal effect to see if once birds are on that nest, are they just not singing as much, but we did not find much of that. So the birds were, so where did the birds go? It could have just been, I didn't observe them, because if they're on territories, they likely wouldn't be moving out of those territories. But in any case, we know that those birds' behavior were somehow affected. As I walked the transect, I may have flushed birds, which may have altered my count slightly. Also, traffic noise may have impeded my observation. However, there have been studies done to show that if you're only looking within 50 meters, which is what my point was from where I was studying, that effect doesn't have as much to do with it. Also, there were weather fluctuations across the summer, which may have had an effect on where the birds were and if they were out and singing or if they were just kind of hiding. And also, we had those wildfires up north, which may have, that smoke came down and settled on the parks, and that may have had an effect as well. Koschelek looked at the effects of visual traffic and also pollution on birds and didn't find any conclusive, but also there may have been some effects on birds for that as well. So lastly, I'd like to thank Bethel University and the C. Weldon Jones Memorial Research Scholarship for funding this project. I'd like to thank Three Rivers Park District, who you'll actually hear from next. I'd like to thank Jeffrey Port, who is my research advisor, and then my mom, Jennifer Swanson, for taking some pictures. Are there any questions?
Hi, I have been over at Elm Creek quite a bit, and that's a really busy road, and so it has a lot of truck traffic. Did you assume decibel level accounted for more truck traffic versus if you're out at Crowhassan, those two-lane roads don't have all that much semis on them?
Yeah, the decibels were definitely louder in general at Elm Creek Park, and that was probably due to that truck traffic, because there were a lot of trucks out there versus Crowhassan. It was more like you'd get like 60 decibels versus Elm Creek was more like 80 at that, especially at that 50-meter transect closest to the road.
I was wondering about you're measuring the decibel level. I guess that'd be the total sound pressure at your location. Would there be any utility in trying to study the frequency present, thinking perhaps that high-frequency sounds don't penetrate a perimeter vegetation screen as well as low-frequency sounds do?
Yeah, that would be another really interesting study. For this one, I just looked at decibel level, but yeah, I think previous studies especially have shown that lower decibel penetrate farther and actually have effects on species as well.
Seems like a lot funner of a senior project than mine, but so I actually have two questions. The first one was, were your point counts, were you detecting birds both visually and audibly? And then my second question will reflect on your answer.
Yes, so it was visually and auditorily. So obviously when the birds are in the trees, it's a lot easier to hear them than to see them, but yes, it was both.
And then my second question is going to be, was there some concern about the decibel level? Was it more of a reflection of decibel level makes it more difficult to detect birds, or is it more of a reflection of actual abundance? For example, I thought it was interesting that birds might be using some habitat not during the weekdays, but then on the weekends.
Yeah, so it wasn't necessarily weekend and weekday because I think they would still be there the whole time. But like during a time of higher decibel level, they might like either their behavior was somehow affected, whether that's they were moving out of the habitat, which may not be as likely if they were on territory, or maybe they are just not acting as active during that time. Something was affected there. Does that make sense? Okay.
All right. Thanks, Erika.